Hello dear friends, welcome back to Math with Amala. Let's move to grade 10 chapter 1 part number 2. Here we deals with the example number 1. Consider the numbers 4 raised to n where n is a natural number. Check whether there is any value of n for which 4 raised to n ends with the digit 0. 4 raised to n means we can give n many values starting from 1 because n is a natural number. 1, 2, 3, 4, etc. We can give any number. Let's give 4 raised to 1, that is 4. 4 raised to 2 is 16. Likewise, if we continue, you will get the 4 raised to n. And the example says it like, check whether there is any value of n for which 4 raised to n ends with the digit 0. So 4 raised to n is equal to some value and 0 at the end means that value must be divisible by 5. In the prime factorization, if we have this number with 0 at the end, the prime factorization must contain 5. But in the case of 4 raised to n's prime factorization, you will get only 2. The only prime number occurring in the prime factorization of 4 raised to n is 2. Hence it is not possible actually because 4 raised to n is equal to 2 raised to 2n. So 4 raised to n contains only 2 as the prime. Thus, by fundamental theorem of arithmetic, you can say that this representation of 4 raised to n as 2 raised to 2n is unique. No other prime is there in the prime factorization of 4 raised to n. So this is a unique factor. Hence, we can say that this uniqueness proves that there is no possibility of 0 at the end for the numbers of the form 4 raised to n. Okay. The next example is example number 2 is to find LCM and HCF of 6 and 20 by prime factorization method. In our earlier classes, we have already dealt with LCM and HCF of two numbers. In those situations, we were using actually the fundamental theorem of arithmetic, but we were not knowing about it. Now we know the theorem and we are applying it into the LCM and HCF findings. 6 and 20 are having the prime factorizations like this. 6 equal to 2 into 3, 20 equal to 2 square into 5. Okay, 20 is equal to 2 into 2 into 5, that is 2 square into 5 raised to 1. So what is the HCF? Highest common factor. Let's take the 2's from it, which means 6 equal to 2 into 3 is having 1 2, 20 equal to 2 into 2 into 5 is having 2 2's. Thus we can say that there are only one common 2, so the HCF is 2. So what will be the LCM? LCM means least common multiple. We can prime factorize them together like this. Then you will get 310 for 2, then again 35 for 2. Then the answer will be 2 into 2 into 3 into 5. 2 square into 3 into 5. 12 into 5. Answer is 60. Here we can find a relation between HCF and the common prime factors. That is product of smallest power of each common prime factor in the numbers. That is HCF. Also between the LCM and the common prime factors we can find another relation. Product of greatest power of each prime factor involved in the numbers. Okay. So we can have different kinds of smallest greatest connections with the HCF and LCM. This thing we have already discussed while we were starting the HCF and LCM concept in this part itself. So HCF into LCM is 2 into 60, that is 120. That means we can make a relation here between HCF, LCM and the product. Let's write HCF of AB into LCM of AB is equal to A into B. HCF is actually 2 and LCM is 60. So you can write 2 into 60 is 120. So this is a common result that we have for two variables or two integers or two natural numbers when they are having HCF and LCM. The product of HCF and LCM is always equal to the product of the numbers. HCF into LCM is equal to A into B. If any one is missing and two are given, we can find the missing number. That means we are having three variables. You can find the missing one using this. Thank you all for watching the video. Please be stay tuned for part 2, which continues with the example number 3 and 4.